Graphing square functions, but this is part 2. So again, if you haven't watched part 1, please go to part 1 before trying to go ahead and participate in this lesson. And in this lesson, we're going to have a little bit more of a guess and check or a discovery type of lesson. So you can see over here, we have a pretty unique type of graph set up, but there's actually 4 different graphs to look at. We have the parent function here in black. And your objective is to figure out then, if black represents the parent function, what would we have to do to that parent function to get this blue graph, to get this green graph, and to get this red graph? So at this time, you can pause the video presentation to see, if you could determine what these graphs would actually look like, or what the equation of these graphs would actually look like. I'm going to go ahead and before I give you the answers, I'm going to give you another hint. And behind here now, I actually have 3 multiple choice. So that way you can associate these expressions with the appropriate graph. So again, if you need more time, pause the video presentation at this time. Or as I unveil one, you can pause and try to guess the other 2. But let's start off here then with this blue graph. All right, if I look at this blue graph, what I see is that the point where I'm starting is still at the origin. That's actually true for all of these, and that's pretty significant. But what's different about the blue graph in comparison to the black is that it's vertically stretched, or it's taller. So what that's going to tell me is it is twice as high, or 2 times the square root of x is what's going to happen. Now, the question becomes, how do I differentiate between the red and the green? Well, there's 2 significant changes here which should help you come up with which one's the correct answer. But I'm going to attack the green one first. If I think back to previous knowledge, I understand that whenever the graph is reflected about the x-axis, that means that there's a negative being applied to the parent function. And so I see a negative in both scenarios, but I want the negative on the outside of the function, not on the inside of the function. This -2, which actually, if I'm not mistaken, we have a -2x, we could see would be the reflection about the x-axis then. So not only is it vertically stretched, but it's reflected down below. So that would be our green graph. Now we can see a negative inside reflects us about the y-axis, and that's how we would get this red graph. Let's actually slide over. That red graph would be now by putting the negative inside the function, which again makes sense because if we think about what's actually taking place there, if I were to use this red graph, that means the square root of -x. So what x values can I put into there? Well, they'd have to be negative. I would have to substitute in, let's say, a -4. So that way the square root of negative times -4, which is 4, would result in a real value of 2. And you can see in the red graph that there's no x values on the positive side because that would mean that we're taking the square root of a negative. All right, so hopefully, even if you didn't get them right on your own, hopefully now you have an understanding of where those shapes actually come from. Let's try this again. But now what you can see, the significant difference is we're now shifting the parent function here in black, either vertically, horizontally, or vertically down. So again, you can pause the video presentation at this time and make a guess at what you think the actual expression would be. If you need additional time or you need additional hints, you can see now I have the 3 expressions written for you. Oh, looks like I wrote them too fast because those 2 are tagged together. So with that being said, let's see which one represents the square root of x minus 6. Well, square root of x minus 6 would mean that we have a horizontal shift. Anything being added inside our function moved everything horizontally. And so our only horizontal shift in this case goes with the green graph, which again makes sense. The smallest number I could put into here would be a 6 because 6 minus 6 results in a 0. And that's the smallest value I could take the square root of because if it's a negative value, that gives us an imaginary. So now from there, we should be able to deduce that the rest of them result in a vertical change. So therefore, x plus 6 is going to be shifting up 6, and then our blue graph down here would be the square root of x minus 6. Again, we take the parent function and we drop every value by 6. So that's just revisiting some of the phase shifts that we talked about in previous lessons. Now let's just go and put everything together. So if I am to graph a function that says negative square root of x minus 1 plus 4, I can envision what the shape's going to look like. This negative means it's going to open down, like so. This means right 1, up 4. So if I'm actually graphing this, I could actually start off and say, all right, I'm going to go right 1, up 4. 1, 2, 3, 4. I know I'm going to open down, but I can actually prove that, right? Because again, if we go back to what we were doing with our table of values, we're thinking about what value of x gives me a 0. That would be a 1. If I get the square root of 0, that's going to mean 0 plus 4 gives me that 1, 4, and which is that coordinate there. Next point, we want this to be equal to a 1. So we're going to put a value of 2 in. So now, if we would actually work this out, 2 minus 1 plus 4, this is negative square root of 1 plus 4. Negative 1 plus 4 results in a 3. So now I have the point 2, 3. And then we have one more point we could actually put in there. If we want to get a 4, I'm going to substitute a 5. So it's going to be negative square root of 5 minus 1 plus 4. Negative square root of 4 plus 4. Negative 2 plus 4, which gives us a 2. So now that means at 5, we're going to be 1, 2, 3, 4, 5. We're at the value 2. And here's our graph like so. Which again, corresponds with what we thought was going to happen. We thought a right shift, a vertical shift up, and a reflection down would be the shape of our graph.